Alright, now we have the camera following the player everywhere, but the background does not look right. From this lecture, we're gonna start working on the background blueprint. And first, we want the background to follow the camera. Let's open BP background. When the game starts, we need to get the camera and keep it in a variable. Let's use the get all actors of class function. For the class, we select BP camera. Then we connect the event begin play to it. So this is going to happen once the game starts. Like I mentioned, the return value of this function is an array, so we need to get the first member. And this one is going to be the BP camera in the world. Next, we need to attach this BP background to the camera. We can do it with the attach actor to actor function. Let's connect the control flow, the target here itself, which is the background. Then we connect the camera to the parent actor. For the rules for the location, rotation, and scale, we just leave them as keep relative. You can also choose to keep the world, location, rotation, or scale. That is going to attach an actor to another actor without changing its location in the world. On the other hand, keep relative means the actor is going to snap to the parent actor. But all in all, what we choose with the rules doesn't really matter here, because we are going to set the transform for the actor very soon. Alright, let's go back to the level and test. It's surprising that we do not see the background at all. But when we detach from the player, we can see the background is there. It's just perpendicular to the world. And in the outliner, you can see now the background is the child of the camera. This is because we choose to keep the relative transform with the attach function. But again, this doesn't really matter, because next we are going to set the transform of the background. Let's stop the game and go back to the BP background. After the attach node, let's set the relative transform for the background. And the function we are looking for is called setActorRelativeTransform. There are too many functions with the keyword transform, so I have to scroll down until I find the function here. Remember that we are trying to set the transform that's relative to the camera. So this is not the absolute transform in the world. Target itself, which is the background. Then we split the transform input. Then we can rotate the background by setting the z value of rotation to 90. Let's compile and go back to run the game. Now we can only see the background. When we detach, we can see the rotation is now correct, but the background is in front of the platform. This is because it's at the same location with the camera, because now its relative location to the camera is 0. I think I need to run the game again to find out the correct location. So let's detach. I'm going to go to the outliner and select BP background. I'm going to move it backward along the y-axis. Then I'm going to check the numbers in the details panel. And we can use the same number in the blueprint. So let me just move it backward. I think here is about alright. Notice that the number that changes is not the y-axis, but the x-axis. This is because we have rotated the background. So the y-axis in the world is the background's local x-axis. This is alright. Just remember the number is 300. Let's go back to BP background. For the relative location, let's set x to 300. Then let's go back to the level to test. Alright, the background is in the right place. And it should fill up the entire screen. If the background cannot fill up the entire screen on your side, you should probably change the width of the camera, because the pixels might be too small in your camera view. Let me test the game again in a new window, because I want to make sure that the background still fills up the screen in the full screen mode. Alright, everything looks good. Let's stop the game and change the mode back to selected viewport, because in the new editor window mode, we cannot detach and check what is going on in the game. Alright, that's it. Let's wrap up this lecture.